Rockets are dangerous, and before we strap our star sailors in, we need to know there's a proven escape plan. Next, on the Rocket Ranch.
EGS Program Chief Engineer, verifying no constraints to launch.
3, 2, 1, and liftoff.
Welcome to space.
Both of our commercial crew program partners, Boeing and SpaceX, are busy getting ready to transport humans safely to and from the International Space Station. But I managed to get a few minutes with a couple folks who provided some insight on critical test flights that are just around the corner. But first, a few episodes back, we had John Cowart in the booth to talk about a NASA-owned abort test. We wanted to tap into his wealth of knowledge to provide a little bit of context. All right, I'm back now in the booth with John Cowart. Thanks for joining me again, John.
My pleasure to be here. Love this.
Hey, so we're shifting focus a little bit and looking ahead to test flights for our commercial crew partners coming up soon. So we have two major tests coming up. Can you explain kind of what's going to be happening for those two tests?
So the first one, so we'll just start with Boeing, and we'll talk about their pad abort test. And what they intend to do is set the vehicle down, and then they're going to pretend like it's a bad day on the ground, and they will do what's called a pad abort. They will fire the abort engines, which would carry the vehicle away in the event of an emergency that occurred on or very close to the ground. And this gives you a lot of good data. This is a test that SpaceX did back in 2015. So SpaceX has got that one under their belt. The next test that's coming up is by SpaceX, and that's the in-flight abort test. That's where SpaceX is going to launch a reused Falcon 9 vehicle with a Dragon capsule on top of it. They will get to right around what's known as max Q. That's where the combination of just ambient air pressure as well as the air pressure of the air hitting the vehicle as you fly through it very much faster. That pressure on the vehicle is at its greatest. They're going to try to abort off of the rocket like there's a bad day there and get away from the rocket at that particular time.
So you mentioned, John, that Boeing, or I didn't hear you mention an in-flight abort test for Boeing. Are they going to be doing one of those later?
Boeing is not going to do an in-flight abort test. They're just going to do the ground one. They think that they can get enough data and then extrapolate that out with good analytical techniques that we've endorsed. They will go and do it in that particular way versus SpaceX, which is going to do both. We knew about this up front, both Boeing and SpaceX, when they proposed their contracts to us and said this is how we're going to get to real flights. We understood exactly, and we bought into it. We think, and we agree with them, that they can get all they need from a pad abort test.
And John, I want to kind of point out specifically that you're very carefully choosing your pronouns,
yes.
The we's and the they's and the us's, and this actually creates a huge kind of complexity to the commercial crew program.
Indeed it does, yes.
And how NASA really engages with these partners. So how does that work with NASA kind of not owning the work, but we're very much invested in it? How does that play out in test flights?
So they own the flight tests. They own, even when they start flying up to the space station, they own the spaceship, they own the rocket. But these particular tests, they own them, which means we will consult with them, but in the end, they are the ones who own the test and the results. Now, they've got to bring that, so as part of their certification, they've got to bring the data from those tests to us before they can go fly our astronauts on board. And we've got to say that, yeah, you got the right amount of data and that the data is good and that the vehicle will perform correctly. But, yeah, this is the thing that's kind of different from the way NASA has done business in the past. We don't own the rocket. We don't own the spaceship. So, therefore, we are it's something more than consulting and something less than owning. It is a delicate balance, and we've had to work real hard with both the providers on this.
And so thinking about kind of just the inherent nature of government versus commercial, do you see a big difference in approach to test flights? Obviously, we're still in the test flight phase. We're not flying operationally. That's not for a little while still to go. So is there a difference in just that inherent approach to these for commercial companies?
I don't think so. I think we've worked with them enough, and they both know what we're interested in knowing, and we've helped them characterize the data that they need, so they understand what has to happen in a flight test. You got to remember, these folks, I mean, while they don't have NASA on their front door, they're still very, very smart people.
Yeah.
And we've been working with both of them for a long time now. We know how smart they are. So they've got this. I feel very confident that when they do these flight tests, they'll get the data that they need and we'll be happy with it.
So I'm going to ask this question. I don't think it's going to have a yes or no answer, but I want to ask anyway. Does everything have to go perfectly in order for them to get the data they need and to really achieve that certification level?
There will be some aspects of the test which I'm sure have to go pretty well in order to characterize it. For example, let's just say the SpaceX in-flight abort test. They've got to be somewhere near max Q, that maximum aerodynamic pressure, in order to get the kind of data that you're looking for that defines the corners of the performance envelope. But otherwise, other things can go very, very differently, and you get slightly different data. Because what you've done is you've modeled this thing. You have a computer model of how everything should work as it goes through this flight test. Whatever the test may be, you've got a model. And so if you were planning to do it at this XY coordinate and you happen to be at ones that are slightly different, well, you can take your model and back it up and go, okay, well, if it had happened here, and so you can still compare your model. And so that's really what you're doing with these flight tests is you're correlating your model to the actual flight performance. So as long as you can connect the dots between what you were expecting and what you got, somehow you can make that model work and see how reliable and predictable it is.
So when I think about modeling, I often think about we do the modeling and then we do the test flight.
Correct.
Is it fair to say that the test flight is helping us calibrate that model for future work to do?
That is 100% correct, yes. That flying the test gives you the data that what we call is it anchoring the model.
Okay.
If you've got real hard data, which is better than just a model, you've got all that you need. You have anchored. That's why we say it. You have anchored the model in testing, and now you can go validate everything, all of your requirements.
And as NASA, do we end up kind of wading through this data with the partners, or do they just have specific pieces that they have to bring to us for the certification process?
So they will not have to bring all of the data, but there is a subset, and by and large, we've discussed this with them up front, and they know what data we need. Some of the stuff is rather low level. We may not need pressures and temperatures at every single point along a certain curve, but we do want to see some aspect of that, and it helps, like I said, to validate their model and their requirements that they've got to go do. So, yeah, we've worked it out with them, and I think we're good.
And just thinking about the listeners out there and just those that will be viewing these, hopefully getting to see these test flights. Yeah. What do you encourage people to look for? Like, what's the takeaway for them as they literally see these things happen?
Well, that's a tough one if you're not used to looking at these sort of things. I know even on the SpaceX pad abort test, when that happened, one of the engines did not perform nominally. And just seeing there and watching it real time, I didn't pick up on that. But when you go back and look at the video afterwards, and clearly when you have the data from the performance of the engine itself, it becomes obvious. So it's hard to see. Obviously, some things, if they go bad, that'll be really obvious for you, especially on the pad, or rather the SpaceX in-flight abort test. When that thing's going up there and somewhere around max Q, somewhere in the neighborhood of about a minute into the flight, you're going to see something you've never seen happen on a SpaceX Falcon 9 rocket before. You're going to see all of a sudden that capsule come popping off. That'll be a really cool thing to see, depending on, especially what time of day. I'm sure we'll want to do that in broad daylight because we're going to have a bunch of cameras trained on it. We're trying to get all the data that we can, and visual data is just as important. Pad abort test for Boeing, once again, just look for good thrust coming off the vehicle and that it seems to perform and fly pretty straight. You got to remember on a pad abort test, you're over land. You need to get over water. That's in order to have your best performance. So you're hoping you watch that thing arc off in the right direction.
So you say get over water, that's referring to when you're actually flying.
Right.
Because I think they're doing it out in the middle of the desert for the pad abort test.
Exactly right. So when you do that test in the middle of the desert, you want to make sure it follows the right trajectory and would have gotten you out over the water.
Gotcha. Okay, perfect.
Thanks for that correction.
Listen, I'm learning too. This is phenomenal. So,
okay.
John, obviously we're excited for Commercial Crew and their work. We're excited for these test flights. So thank you once again for joining me here in the booth.
My pleasure. And I hope everybody gets to see one of the tests. It'll be really cool. I know you'll be able to see it on the computer somewhere, but seeing them live is really cool.
First up for our partners is Boeing's Alicia Evans on their pad abort test. All right, so I am in the booth today. However, my guest is joining me by phone. I have Alicia Evans, who is I believe, test article integration lead for Boeing's CST-100 Starliner. Alicia, thanks for joining me.
Thanks for having me, Joshua.
Did I get all that correct?
Yeah, so I'm the test article integration lead for Commercial Crew Starliner for our pad abort test article.
Which is awesome. Like, you're working on a spacecraft. Like, that's pretty cool.
Absolutely. I always enjoy getting to tell people I test spaceships for a living.
A brief update. Since this interview was recorded, Alicia has actually been promoted. Her job is now flight director for Starliner's pad abort test. And I know you were telling me a little bit earlier about your history actually working on other spacecraft. Can you give me kind of a quick overview of the kinds of things you've done in your career so far?
Yeah, I've gotten to work on two major projects for satellites. So the very first program I got to work on is a NOAA-NASA project called GOES. It's our Geostationary Operational Environmental Satellite. This is a satellite that monitors the Earth continuously, 24 hours a day, 7 days a week, 365 days a year, watching our weather. And for those that are really concerned about hurricanes, this is the satellite that creates those beautiful satellite images of hurricanes. But it does far more than that. Has search and rescue capability on it, gets data on how weather is developing every single day, right? Which feeds into our model predictions for weather forecasting. And then in addition to that, it watches our space weather. So it looks at the sun and our local environment and tells us what type of space weather Earth is going to be impacted by.
That's awesome. Yeah, obviously, us being in Florida on the Space Coast, and then the launching of the Starliner being here as well, hurricanes are a big deal because weather's a huge factor for launch. But you actually, the reason you're coming to us by phone is because you're not where we're going to launch the Starliner into space. You're somewhere very different. Can you explain where you are and kind of what activity you're kind of going through right now?
Absolutely. So today, I'm actually in New Mexico. We're at the White Sands Missile Range. It's an Army base in South New Mexico, where we are going to be conducting the Starliner pad abort test. So essentially, we are executing a flight test of the Starliner vehicle that's going to demonstrate the fact that we can safe our astronauts in the case of a bad day scenario with our rocket, right? So we want to make sure that our astronauts are safe, and this is a demonstration of that capability.
So before we get into the test some more, can you kind of talk me through, so people have a pretty good picture of what a rocket on a launch pad looks like. So let's say that this bad day scenario plays out. What are people going to see from the launch pad on this day?
So, at the launch pad, right, you have the rocket standing next to its gantry. We have a launch vehicle adapter, which essentially is structural hardware that adapts the launch vehicle to the Starliner. So that's how we interface to it. Then you have the Starliner sitting on top of the rocket. And we have a service module as well as a crew module, which is the Starliner, so two parts. And during a abort, right, if there was to be an accident with the rocket and we needed to save the crew, what would happen is we have 4 large launch abort engines that fire in conjunction with several more smaller thrusters called our orbital maneuvering and attitude control thrusters. And that combined collection of thrusters lifts the Starliner away from the rocket and outside of any debris or blast zone that might be created by a rocket.
Now, when you say lift, I'm assuming that if you're talking about an exploding rocket, lift is actually at really high speeds. Is that a fair assessment?
It is. I actually don't have the speeds directly in front of me, but those 4 big engines, the launch abort engines, are firing 40,000 pounds of thrust each. And then each of those smaller thrusters, and we have 12 of them, are adding an additional 1,500 pounds of thrust. So it is moving very, very quickly away from that rocket.
And so thinking about that scenario, obviously you're out in New Mexico where you don't have a rocket. So what's this test look like without a rocket?
So what we've done is we actually have a launch stand that represents the height of the rocket, but ULA, our Atlas rocket provider, has provided us with flight hardware that we're interfacing with. So we have what we call a Centaur forward adapter as well as a launch vehicle adapter. And as part of our launch vehicle adapter, we have an aeroskirt, and that's all flight hardware from ULA that'll be part of this test. And so it'll adapt to our test stand, and then the Starliner will sit on top of the launch vehicle adapter just like it would on launch day.
And so on this for this pad abort test, where will you be? Obviously, kind of your integration. So in my mind, I picture you working more to kind of make sure things are in place come test day. Do you have a function on that day?
So that's a great question. I'm really hoping to be a spectator on that day, but we will see what role I might ultimately fill launch day itself. Our launch team is actually going to be a few miles away from the launch pad, roughly about 4.5 miles away. And we are at a facility called the Wismar Cox Range facility, and we'll be doing all of our operations from there.
And so thinking about that launch team, is that the same team that will be present for actual flights of Starliner?
Absolutely. So we'll have kind of break the team down into different groups. We have a mission control team that is located in Houston. They're participating in this flight test just like they will for a real mission. And our two other test flights, the orbital flight test as well as the crew flight test. So they're in Houston, and they're going to stay in Houston for all three of these activities. Then we have our local Starliner test team, and their job is to power the Starliner itself and get it configured for launch and ready to hand over to start the test. And that team is going to participate in all of our flights, getting us ready for the pad abort test as well as the orbital flight test, the crew flight test, and all of our future missions. And their job is to make sure that the vehicle is configured and ready so that when T0 happens, liftoff, I think we actually hand over a few minutes before over to the mission ops folks. But they've made sure that the vehicle is fully configured and ready to launch.
Cool. So obviously there's a big difference from your work with satellites to the Starliner. The biggest difference probably being the fact that humans are on board the craft when we fly to space, which has got to be pretty cool. Are they involved in this test? Are you going to have astronauts present, whether it be in the spacecraft or locally nearby?
So I actually haven't closed with the crew to find out whether or not they're going to be here to witness. They are not going to be in the vehicle. So during the pad abort test, is same as the orbital flight test, we're going to have an ATD. It's I call them a crash test dummy, but essentially
anthropomorphic test.
Yes.
What's the last letter?
That's where I was getting hung up. Yeah, we'll have an anthropomorphic. It might be test dummy.
Let's go with that for now.
Participating as our pilot for both the pad abort test and the orbital flight test. And so we're actually getting him integrated today. He got all checked out this morning, and later this week we'll actually get him in the seat.
That's awesome. So is this Starliner? Is this a full up Starliner, or is this a mock up?
This is a full up Starliner. So it's been built up specifically for this test, but because we are testing the integrated system, it has all of the systems required for the pad abort test, and it's full up avionics capability, propulsion. There's a handful of things that we've mocked up just because we wanted to keep the flight hardware for later use. So because our pilot is a ATD and doesn't have any eyes like our integrated crew panel, which is what the crew uses to keep tabs of what's happening on the vehicle. That's been mocked up. So that's a mass simulator during this launch, just because we wanted to keep the real flight hardware for use later.
So I know that the Starliner in general has been designed for reuse. And so will this Starliner have an opportunity to fly into space later, or is this one really kind of it's a full Starliner for this very specific use and then it will be retired, so to speak?
That is a great question. We're still debating about it.
Okay.
This vehicle actually has the capability to fly again later, although right now, I believe in our plan it's a single use.
Okay. And so thinking about crews not being involved on this day, do crews actually train in some way for this kind of a scenario? Obviously, we hope we never have to use these kind of skills, but are they training for what's it like to go through this sort of a situation?
Absolutely, right? So the crew goes through significant amount of training, and a lot of what they're going to be training for is what to do in the case of an abort test, right? And so they go through and prepare themselves for the sequence of activities that are going to happen. And then the only real difference, I think, in their training is going to be whether or not they don't really get to experience the G's that they're going to feel in the abort test. But so much of how we design this system represents what they're already going to feel for flight, that it's not going to be significantly different for them sitting in their seat compared to what they're going to experience during a real flight. But what we do train them for is how to handle, how to know that they need to trigger an abort, what to expect as soon as an abort is triggered, because aborts can be triggered both autonomously from the vehicle sensing an issue, from the Starliner sensing an issue, from the rocket sensing an issue. Both of those send signals across our interface and tell the other system, hey, we need to abort, and then initiates an automated sequence. There's also two manual capabilities. So the crew themselves can actuate an abort. We have an abort handle that they have to pull to initiate an abort, or the ground crew at the Mission Control Center can say, hey, there's something happening, we need to abort the mission and save the crew. And they can send a command that will also initiate an abort. And so once that happens, the crew now knows, okay, I'm going to get the following sequence of events. And they're going through training that prepares them for what that looks like. Great.
As you think about this day approaching and you hopefully getting to be a spectator, as you said, what kind of feeling do you think this is going to have for you? Like, as you watch this thing fly and hopefully everything goes brilliantly well, what's that feeling like for you?
Oh, I'm very excited about this test. Right, this is a full demonstration of our landing sequence. Right, we have done a lot of subsystem tests of our landing sequence to show that each component works individually, and in addition to showing that our propulsion system works to safe the crew away from the rocket, the second half of the abort test is that it lands on land the way it would during an actual return from flight. And so what we're going to see is the service module separating from the crew module. Nominally, you don't get to see that because that happens as the vehicle enters orbit, as the service module burns up in the atmosphere and the crew module comes in safely through the atmosphere. So this will be an opportunity for us to actually see that separation event. And then the forward heat shield pulls away. We got parachutes that fire and then pull that forward heat shield away, which expose our main parachutes. And then we'll get to actually see our parachutes deploy and billow out as the reefers allow it to billow, and see the crew module starting to float down. As we get closer to the ground, we'll see the base heat shield separate, which exposes our airbags. And then as we get closer to the ground, the airbags inflate. And that entire sequence, this will be the first time that's demonstrated as on-flight hardware in the air. So I'm very excited to watch all of that take place and then land under parachutes on airbags on land, which is the first American vehicle to do that.
Alicia, just hearing you explain that as a spectator, it's a fun thing to get to watch this happen successfully. And you saying all that makes me appreciate even more how involved and difficult this is. So a huge congratulations now and for the future for you and your team. We're excited to see this thing fly, and obviously we're excited for you guys to transport humans safely to and from the International Space Station sooner than later.
Thank you. Yeah, I can't wait for this flight and our next 2 test flights and get into future missions.
Awesome. Alicia, I appreciate your time. Thank you so much for joining us today.
Thank you for having me.
Because Alicia got promoted to flight director for this test, she won't be able to be just a spectator, but we wish her and the entire Starliner team good luck. And now on the SpaceX side, here's Benji Reed to talk their in-flight abort test. All right, I am not actually in the booth now with Benji Reed because he is coming to us live from SpaceX headquarters in Hawthorne, California. Benji, I understand you're the Director of Crew Mission Management, is that right?
That's right.
And can you explain kind of what exactly does that mean? I know that you work a lot with commercial crew, but what's your function really like?
So ultimately, my job is to kind of help make sure that the contract gets executed well, that the whole mission and overall program work well. It's coordinating all of the great engineers that we have here at SpaceX and all the great engineers that are at NASA, and make sure that they work together to ultimately get our system reviewed and certified for flight. And then, of course, doing the operations, because then we have our whole operations team that works with the crew to go fly them to station and bring them home.
Yeah, so excited. Obviously, that's why we're here today talking. You guys have your in-flight abort test coming up, and we'll kind of explain why in a minute. But you guys lost a Crew Dragon capsule earlier this year, and throughout the course of human space exploration, we have seen a history of these kinds of seeming like just setbacks, these difficult moments, proving to make us smarter and make us better and improve our hardware. Have you really seen that happen with SpaceX over the course of the past few months?
Absolutely. And I've seen that with SpaceX over the many years that I've worked here. Elon said the other day that if you're not breaking things, you're probably not testing hard enough. And so we love to test and test and test. We don't always like to break things. And of course, the anomaly that we had earlier this year was tough, but it was, as has also been said a number of times, it was a gift because we learned a lot. We learned a lot about our system, but we learned a lot about the nature of the materials and how these systems work in interaction. That is actually going to be industry leading and help all spacecraft become safer. So for sure, when you have problems, you jump right into them, you get a lot of data, and you get better for it.
That's so awesome. And the reason I kind of bring that up, actually, if I understand correctly, that Crew Dragon was supposed to be the one flying on in-flight abort. Is that true? And can you kind of speak to what's been the process in light of that moving forward to obviously keep charging ahead?
Sure, absolutely. That was the capsule that was originally slated to be for in-flight abort. In fact, that's why we were doing the testing, was we were basically initiating the Dracos and then also the Super Draco engines on that vehicle in a static fire arrangement, getting ready for an in-flight abort test. And the number one impact, of course, is, hey, we got to figure out what went wrong, and,
sure.
We've done that now, and then figure out what the best way is to mitigate that anomaly and make sure that it's not going to happen again on the future. And that's your very first concern, of course. And then, kind of a close second is, all right, so what are we going to go fly for the in-flight abort test? The good news is that we have lots of capsules in build here all the time. And so we had the next capsule in line, which had been originally slated for the Demo 2 test, coming up soon, and then also other capsules beyond that. So we just shifted the whole capsule line assignments ahead one, so that what had been for Demo 2 is now going to fly in flight abort. The Crew 1 operational mission will now be for Demo 2, and so on. And it was great. We're able to do that, and that's a real testament to our production team and their ability to function.
Yeah, so cool. So thinking about the in-flight abort test, because obviously that's the next big one on the commercial crew path here, can you kind of talk our listeners through, like, what should they expect to see when this mission takes place? Because this is not a normal thing.
Right. That's exactly right. It's, it is a test. number one, and it's a test of our escape system, which we hope to never actually use.
Sure.
Right. The escape system is how we get the crew away from the launch vehicle in case something's going wrong, and we want to get them away really fast and bring them back home on parachute safely. And so what you're going to see is it first will look a lot like a normal launch, right? There's going to be a Dragon on top of a full Falcon 9. That Falcon 9 will launch off of 39A, just like we've seen before, like we did on Demo 1, which just flew back here in the spring. And that launch will go off, and a little ways into flight, will initiate the launch escape system. Those Super Dragos will fire, Dragon will separate from Falcon, and the Dragon will move very quickly away from Falcon and then come back on parachutes. In terms of what people will be able to see, it will be probably not a lot. It depends on how clear the day is and the weather fundamentally.
Yeah, so are you guys going to be trying to return this Falcon, or are you going to be simulating like a full up, like, hey, we had a really bad day?
Oh, that's a fair question. So we're not going to necessarily simulate something going wrong with the Falcon, right? The goal is to say, well, the system has detected something's gone wrong with Falcon, and now it's going to get those astronauts away safely. That's the simulation. So the main thing is testing the Dragon can get away safely from the conditions that it's in on the Falcon. However, that said, we do expect that this Falcon will break up. Falcons are designed to get us to orbit and then come back home and land, but they're not necessarily designed to halfway through their ascent have their payload pop off. So we're gonna expect to see that the Falcon will probably break up at some point after Dragon initiates its escape.
And so does this mean there's a physical button that somebody's going to hit, or is this a timed activity?
It's a timed activity.
Okay. And you mentioned the Dragon's going to come back on parachutes. Are we going to see a recovery like we saw with Demo 1, or are we going to see a full-on simulation of the recovery effort as if there were people on board?
You know, that's a great question. In fact, we've already had a chance to practice this. If you remember back in 2015, we did a pad abort test where we did the same thing, where we initiated the launch escape system on Dragon, but from the pad. And that was about 4 years ago. And we were able to learn a lot from that, including the recovery efforts. So that Dragon launch escaped from the pad and then came back down into the water on parachutes, and we had our recovery team go out and pick it up. We'll do something similar in this case, where we'll have our recovery team and their vessels staged and ready to go. We'll also actually have the search and rescue forces who would be on call for an actual, escape or off nominal landing, as we call it. We want to have everybody take the opportunity to practice and do a lot of what they would do kind of around this event. They won't do the full thing. It won't be treated as a full search and rescue practice mission. We've actually already been doing a lot of that over the last number of years. But everybody will be staged and able to exercise some of what they would do in a real situation.
That's really cool. Will you be planning to reuse this Crew Dragon at some point?
Yeah, certainly. We'll bring it back, and the first and most important priority is we'll get all the data off of it from the test. We'll inspect it, understand how the whole vehicle looks, and then we'll eventually, I imagine, we'll probably refurbish it and decide to figure out what we would use it for.
I'm just envisioning like this whole thing happening. It's going to be pretty awesome. I understand that the abort simulation is supposed to happen around the time of max Q, or maximum dynamic pressure. Is there a reason that you guys chose that moment? And are you expecting that there's going to be any sort of negative impacts to the Crew Dragon as a result of that?
Good question. So no, we don't. Part of the point of this test is to validate that Crew Dragon will withstand this test and withstand this event, and again, bring the crew home safely. In terms of the timing of it, that's actually a really interesting point. So it happens just a little bit after max Q. And what we've done is we've looked at all of the different places where you really care about the intense forces, intense aerodynamic forces, and that are going on in the vehicle. There's these different places where you could look. Right at initiation of the shutdown of the primary engines. You can look at where your parachutes are going to deploy. Kind of there's this whole range of, I could test here, I could test there. And what we've done is we've tried to optimize for the maximum opportunity across all of these different areas. So we've chosen a time, a point in the timeline that kind of gives us the best representation of a tough scenario for all of those different things that can be stressed in the system. And that's optimized so that we kind of get the biggest bang for our buck out of this test.
So it sounds like you're kind of saying this is like the worst case scenario of the worst case scenarios. Is that a fair assessment?
We try to. I wouldn't. I don't know if I'd quite classify it that way, because that often drives you to what we call the corner of the box, right? It's
Sure.
like you take this most extreme case,
Sure.
and you go test there. And the reality is that in a timeline like this, there's a lot of corners of the box. And instead of just testing one of those corners for this test, we want to make sure that we actually get a good representation across as many areas as we can. So we've optimized in that way.
Okay. And you mentioned that this Crew Dragon was originally planned for Demo 2. Obviously, plans changed a little bit. So will this Crew Dragon be fully built out, or will it kind of be more of like an essential package to test these critical systems for a launch abort scenario?
Sure. So the vehicle is complete as far as is needed for the test. There are a few elements that aren't installed because they're completely unrelated to the test. For example, the docking system. And as you recall, that really cool docking system that we developed and that was tested on the Demo 1 flight back in March. There's no need to have a docking system on this particular test vehicle, right? So we've removed that system and have in place a mass simulator. So we get all the same forces, all the same effects of having that mass there on top, but it doesn't need to be an actual mechanism that works. So that's one example of something that we've taken off of that vehicle. But otherwise, it's a complete Dragon.
That's great. So for launch day, for in-flight abort test, where will you be? Are you going to be out here at the Kennedy Space Center? Or are you going to be on console somewhere? What's your role that day?
Oh, absolutely. I plan to be at Kennedy and in Fire Room 4, where we'll be running the mission. This is a launch. And,
Sure.
We've asked all of our teams to view this as a full-on mission. It doesn't quite make it to orbit, and it's not a long-duration Dragon mission, but it is a mission. We are launching a rocket, and something very exciting is happening with the payload halfway through that ascent. So we're treating this as a full-on launch. We'll be in the firing room, and I'll be out there at Kennedy, just as I was when we did that pad abort test back in 2015, and as we were there for Demo 1, and in fact, I'll be out at Kennedy next week. We get to come out there a lot, and we have a strong team that's resident there, and a lot of my folks get to go there a lot. And right now, in fact, down at Kennedy, our teams, our integration teams, are just going gangbusters, working on the Dragons. Both, of course, the in-flight abort Dragon. They're getting ready for that to move into our static fire test. They're also getting ready for upcoming CRS Dragon missions, cargo Dragon missions. So our work both at Cape Canaveral Air Force Station as well as at Kennedy is constantly ongoing.
Yeah, it never seems to stop. Obviously, you guys have a high rate of launch here. That's great. I know for Demo 1, I believe you guys had and you'll have to forgive me, I'm blanking on the technical term. You had a dummy on board that's quite smart. Ripley, I believe. Are you doing anything like that for in-flight abort?
That's right. We did. We had Ripley on board for Demo 1, which allowed us to gather a lot of data. And we're doing similar data gathering for the in-flight abort test. We have a lot of sensors in place. We have a lot of sensors of what the crew would see and feel. So we're doing a similar process where we gather data.
And I know this whole test is definitely a part of getting to that point where we have that confidence in sending crew aboard Crew Dragon. So what are some of the things, kind of the highlights of the challenges of going from Demo 1 to Demo 2, other than obviously this test?
Absolutely. So the biggest thing, of course, is building out the vehicle as a first step. I'd say that of equal priority and importance is having the crew ready to go and our ground teams ready to go in terms of training. We need to make sure that all of our qualification testing has been complete, and then finally make sure that all of our certification is complete. So you kind of have to build the whole system that's going to launch us there, right? There's the Falcon and the Dragon and the ground systems, and then there's having all of that tested and complete. There's having all of the operations teams ready to go, the crew themselves ready to go, all of that operations procedures and practice and training in place. And then there's the certification of the whole thing, the hardware, the software, and all of that operations ready to go. So it's been a lot of work to complete that process. But the good news is that we had a ton of it done leading up to Demo 1.
obviously you guys have a series of missions that you're on contract for as part of a commercial crew for missions to the space station. But what's life for Crew Dragon beyond that? I'm assuming that there's more to it than that with SpaceX's goals and missions.
Absolutely. The point of the commercial crew program from NASA itself is to help foster commercialization of low Earth orbit. And that's part of this program. And so the ultimate goal is that we can take all of these great assets that we've developed and start to put together commercial access to space for private passengers and commercial passengers and whatnot. And we're already having conversations along those lines to look for those kinds of missions.
Awesome. Yeah, so thinking about our listeners, Benji, is there anything else you want to kind of leave them with? Obviously, an exciting year ahead of us, but I'll kind of let you have the last word here.
Great. Yeah, first of all, I appreciate the time and appreciate the opportunity to be on your podcast. And, just keep your eyes wide open. It's going to be an exciting next few months coming up.
Cool. Benji Reed, Director of Crew Mission Management for SpaceX. Thanks so much, Benji.
Thank you.
I'm Joshua Santora, and that's our show. Thanks for stopping by the Rocket Ranch. Special thanks to our guests, John Cowart, Alicia Evans, and Benji Reed. To learn more about the Commercial Crew program, visit nasa.gov/commercial crew. And to learn more about everything going on at the Kennedy Space Center, go to nasa.gov/Kennedy. Check out NASA's other podcasts to learn more about what's happening at all of our centers at nasa.gov/podcasts. A special shout out to our producer, John Sackman, our sound engineers, Michelle Stone and Lauren Maythree, editor Michelle Stone, and special thanks to Stephanie Martin, Tori McClendon, Marie Lewis, Jen Wolfinger, Jessica Londa, and Ava Barron. And remember, on the Rocket Ranch, even the sky isn't the limit.